Hey class, in today's lesson we're going to talk about counting principles, which is found in section 9.6 part 1. Our objectives are to solve simple counting problems, to use a fundamental counting principle to solve more complicated counting problems. So for example 1, it is selecting pairs of numbers at random. So the question says 8 pieces of paper are numbered 1 to 8 and placed in a box. One piece of paper is drawn from the box, its number is written down, and the piece of paper is replaced in the box. Then a piece of paper is drawn again from the box, and its number is written down. Finally, the two numbers are added together. How many different ways can a total of 12 be obtained? So what we want to focus on is the fact that they are drawing it one time and 2 times. Okay, so the first number, or the first time it's drawn versus the second time it's drawn. If I'm trying to get a total of 12, the only combinations I can have is that the first time I draw a 4 and then I draw an 8 the second time, giving me 12. I can draw a 5 the first time, draw a 7 the second time. I can draw a 6 the first time and draw a 6 the second time. I can draw a 7 the first time and draw a 5 the second time. And then finally I can draw an 8 the first time and draw a 4 the second time. All 5 of these ways are ways that I can obtain 12. So the different ways you can get a total of 12 is 5 ways. All right, let's take a look at our next example. Our try says a very similar situation. It says 8 pieces of paper are numbered from 1 to 8. 2 pieces of paper are drawn from the box, and the number on the paper, or the numbers on the paper, are written down and totaled in the order they were pulled. How many different ways can a total be obtained? So this one is a little different because this one says that they are drawn at the same time. So if they're drawn at the same time, sorry, they're not drawn at the same time. 2 pieces of paper are drawn. If I have my first time again and then my second time, the first number that I could draw could be a 4 and then an 8. I can draw a 5 and a 7. I can draw a 7 and a 5, and I can draw an 8 and a 4. In this case, the number 6 that we had last time is not available because there was only 1 6 placed in the box, not 2 6s. So that does not work. So again, there are only 4 ways for this problem. All right, let's look at the next one. So just some background information. The difference between the counting problem in example 1 is that example 1 had replacement, whereas try 1 did not have replacement. So again, that eliminated the possibility of choosing 2 6s. All right, so let's talk about the fundamental counting principle. So it says let E sub 1 and E sub 2 be 2 different events. The first event, E1, can occur in M1 different ways. After E1 has occurred, E2 can occur in M2 different ways. The number of ways that the 2 events can occur is M1 times M2. So let's take a look at an example. So in example 2, it says using that we're supposed to use the fundamental counting principle. So it says how many different letters from the English alphabet are possible, or different pairs, excuse me, that was clearly said, how many different pairs of letters. So if I have a pair, that's the first letter and the second letter. So for us, there are 26 possibilities for the first letter and 26 possibilities for the second letter. So what we would do is 26 times 26, which is going to give us 676 possibilities. All right, let's look at our last one. In example 3, again, we're dealing with counting telephone numbers. So it says telephone numbers in the U.S. have 10 digits. First There are 3 for the area code. The next 7 are the local number. So it says how many different telephone numbers are possible within each area code. So for us, if we think about it like this, if we think about our local number, because it says within each area code, so we're not having to do the spot for the area code. Local numbers have 7 digits, so that's 1, 2, 3 digits, and then it has the last 4 at the end. Okay? Technically, there are 10 possibilities for each number. However, the very first number, usually you don't have a phone number start with a 1 or a 0, so really there are only 8 possibilities there. So if we multiplied them all together, we would get 8 million numbers within an area code. 8 million possibilities. All right, guys, that's it. Actually, we had a pretty short lesson. So if you have any questions, please be sure to come see me for tutoring.